Okay, so the first problem is just the square root of 6 times the square root of 6. If they're both under the radical, then you can multiply them. The square root of 6 times the square root of 6 is the square root of 36. And that actually is a perfect square. So the answer to the square root of 36, because it is a perfect square, is just an integer answer of 6. That is our answer. Now for letter B, you should notice that you have numbers in front of the radical and numbers underneath. So the numbers in front get multiplied, and that is the 5 and the 2. The numbers underneath get multiplied, and that is the 10 and the 5. So this is equivalent to 10 root 50. Here's the problem. You can simplify the square root of 50, and we need to do that. In order to do that, I'm thinking in my head, what is a perfect square from my list above? What is the largest perfect square from that list that divides into 50? So obviously we start less than 50. 49 does not divide in evenly. When I say divide in, I mean evenly with no remainder. 36 does not, but 25 does. So the 10 stays where it is. The 50 transforms. It's like working backwards for multiplication to 25 and 2. And then I know the square root of 25 is 5. I don't know the square root of 2 to be a whole number or integer. So 10 times 5 becomes 50 root 2. So this whole thing, this original problem, is equivalent to 50 root 2. In our next example, this one's a little bit easier because you just have two radicals. So you're going to get the square root of 48. And again, from our list above, what's the highest number that divides into 48? Not 36, doesn't go in evenly without a remainder. Neither does 25, but 16 does. 16 goes into 48 3 times, so 16 times 3 is 48. I know the square root of 16 is 4. I don't know the square root of 3, so I get 4 root 3. Sorry, that's my dog. Letter D, you have a negative here, so you're going to multiply and get negative square root of 36. And, oh, another 36. So I know that. That's just going to be negative 6. That is a perfect square. I don't need to break it down. It's great the way it is. Here, numbers in front get multiplied. That's negative 6. Numbers underneath get multiplied. That's 15. When I look at my list of perfect squares, if it's 15, 9 does not divide in evenly. 4 doesn't divide in evenly. 1 does divide in evenly, but it's just 1 times 15, so that wouldn't change anything. So this is the best you can do for this problem. That is the answer, and that's okay. Letter F, the 4 is in front. Nothing's in front here, so it's an implied 1. 1 times 4 is 4. 5 times 15 is actually 75. And from my list, the highest perfect square that divides into 75 without a remainder is 25. And I know the square root of 25 is 5, so I have 4 times 5 in front. I don't know the square root of 3. These are both in front, so they get multiplied together. So when all is said and done, the answer to this problem is 20 root 3. All right, not so bad. Pretty easy. You just get the hang of it. Takes a few times, but you'll get it.